Assalamualaikum. Saya Dihar Bakri merupakan ikon Pusat Sumber Sekolah. Anda sedang menonton Global TV Pusat Sumber.
Light-dependent reaction consists of cyclic and non-cyclic photophosphorylation. First, the non-cyclic photophosphorylation consists of two photosystems, which is photosystem 1 and photosystem 2. The non-cyclic photophosphorylation starts from the photosystem 2, where the accessory pigment receive the light energy, absorb the light energy, and pass the energy to the primary pigment, which is the P680 in the PS2. And the electron inside the P680 was excited and passed to the primary electron acceptor, which is the 3015. And then the electron will pass to the electron carrier, cluster Q9, then to cyclotron B6F complex, then to plastocyanin, and then go to the photosystem 1. So the production of the ATP by process of chemical osmosis was occur in the cyclotron B6F complex, where the flow of the electron will provide the energy to pump the proton from the stroma to the thylakoid space and create the electrochemical proton gradient. So then the proton will diffuse back into the stroma down the concentration gradient through the protein known as the ATP synthase. The ATP synthase will use the energy of when the proton diffuse back to combine ADP and PI to form the ATP. So the electron now is in the PS1. It receives the light energy by the accessory pigment, and the energy is passed to the P700, the reaction center of the photosystem 1, and electron excited, and the electron was passed to the FES, the primary electron acceptor for the PS1. Then the electron will pass to the ferredoxine, and then lastly will go to the NADP plus reductase. The NADP plus reductase will donate the electron to the NADP plus to stabilize it to receive the hydrogen from the photolysis of water to form the product NADPH. The product NADPH will then release to the stroma to undergo for the usage of the dark reaction. Now for the cyclic photophosphorylation, is only involve the PS1. So the light energy was absorbed by the accessory pigment and passed to the reaction center P700, and electron is excited and passed to the primary electron acceptor to the FES. Then the electron will pass to the ferredoxine to cyclotron B6F complex, then to plastocyanin, and lastly go back to the photosystem 1. The production of the ATP in the cyclic photophosphorylation is same like the non-cyclic photophosphorylation, where the flow of electron will provide energy to pump the proton and create the electron chemical proton gradient, and the proton flow back into stroma, and the ATP synthase combine the ADP and PI to form the ATP. So for the photolysis of water, is only non-cyclic photophosphorylation will involve the photolysis of water, because the electron will not flow back to the photosystem 2. So to replace the electron loss, it will take the electron from the photolysis of water. So the process of photolysis of water is like it receives a light, water molecule receive light energy and split into hydrogen, the OH ion, and the electron. The electron form will be replace the electron in the photosystem 2. The photosystem 1 will not involve the photolysis of water, because the electron will flow back to the photosystem 1.